Hi everybody, this is Samir, and today we get just a quick one, but it's more a tip than a tutorial. So a quick tip, and I just would like to show you this because I see so few, or actually no animations at all that use this. And so let's just create a liquid setup, and we have the default setup, which when I play the simulation, simply flows out of a spherical volume into the container and starts filling it. All right, pretty boring. I agree. So let's give this a bit more spin. And when I'm talking spin, I'm talking about nice looking motions. And for this, we use the vorticity particles. Really, it's I haven't thought about it myself that much, but lately I was playing around during the development of version 2, and I came across, surprisingly again, my vorticity particles and really experienced this. So I just wanted to share that. And in the solver simulation tab, we have the turbulence mode, and I set this to vorticity particles. And so now I got that option here, vorticity particles in my emitter. And let's just create some. We can see they're displayed in red here. And let's just take, let's say 50. All right. And when I play the simulation, nothing happens because we have the intensity set to 0. And I just lengthen this simulation now so we can see what happens while I'm playing around here. So let's just put this to 0.2, for example, with the default settings. And we can see down here that we get a slight to the sides now due to the turbulence that is introduced by the vorticity particles. And at this resolution, we have a radius of 3 grid cells. So it has a pretty high influence. And let's put this higher, say to 0.5, and we will see an increase in vorticity here soon. Now it's starting to give this more wavy motion. And let's just go a little bit extreme, put this to 2.5. And we only have 50 vorticity particles, and we can see now here a big vortex forming and splashing around all that water. So we can create pretty nice turbulent motions and control the size, the feature size, with our vorticity radius here and the vortex stretching. We also have different fall-off types. So, and of course the resolution is a dependency. So let's go back to 0. It's becoming a little slow here now with these much particles, and let's just increase the grid cells and also maybe a little bit of volume to the emitter. So we have just more particles available for the effect. And going back to my vorticity particles and starting again. And we don't have less effect because the particles, of course, still have that same radius. And you can see we get a pretty swirling up motion here. And okay, so let's just take a look at the settings, and I put this down to 1, for example. Let's do this again. What I do is I lower the LOD of the fluid particles. So I can have a little more speed in my editor window. All right, that looks fine, but we still have so many particles. So I reduced the size of the emitter again just to speed this up a little. All right. So, and now I can play with my settings here to get different kind of effects. Using different kernels will result in different or less influence inside of the radius of the vorticity particles. And let's just put this, for example, to the spiky one. We get a more spiky distribution, more spiky turbulence here. 0.5. I'm just playing around here, so that's actually how I always do it. I check out the feature, I make a simple setup and start playing with the settings to see the effects of the changes, right? And if I lower the vortex stretching, which is the parameter that defines the, how can I put it, the folding of the motion. So how fast and how stretchy a vortex in the turbulence becomes, right? So here now we have a much lower extent of the effect. It's not that stretched. The folding doesn't happen that fast because we have a lower vortex stretching force. And well, especially when you're having kind of rivers or something flowing down certain areas, or maybe bumpy stairs, and you want a little more come on, I don't find the English word now, a little more jumping when they collide with the steps, for example, of the stair. You could simply put your vorticity particles on the step, and once the liquid hits the step, it gets more turbulent and more splashy. So that's the great thing about the vorticity particles. You can place them wherever you want, and you can that way control where the turbulence really happens. And of course, this happens. This works for liquid particles in the same way as for the gaseous simulation. So for smoke and fire and all that stuff, you can define with the vorticity particles pretty well where turbulence and how strong turbulence happens. And that's just a quick tip. And I hope you start using it because it's a great feature. Bye-bye.